Now this is where I'll go over line by line on the sensor software and my solution. Your mileage may vary and you're welcome to come up with your own solution before looking at this, but it's here just in case. We'll go over the various sections, and I've broken this up into 3 sections. The beginning pin and variable definitions, the setup routine, which does the initialization, and the loop, which will then loop forever, sampling the sensor and displaying the results. So we've got a small area of definitions. I'm going to introduce the constant definition here, where I'm doing a constant. And constant is different than declaring it just as an integer. It tells the compiler that's the number I want to use for that name, but you do not have to allocate any storage for it. So when you have a lot of constants, it's much more efficient to declare them as constants as opposed to declaring them as a straight integer and requiring the processor to set aside memory for it. Here we have the LED pins, and then we have my variables that we'll use. I'm going to sample the counts, and then I'm going to create a value called null counts, which are the counts at the null point, and then diff counts, or the difference between the null and what I measured. And there's the integer I, which I'll be used as a loop counter. We'll introduce a for loop, and then a sample sum. We'll be summing 8 samples together, and then we'll use that to create an average. So here's my setup. First thing I do is I start up the serial port, 9600 baud. Then those 3 LED pins, I'm going to define those as outputs. And this next part here, I'll take my sum, set it to equal to 0, and then this for loop structure. And what the for loop does, it says start with I equal to 0, and as long as I is less than 8, increment through this loop, and we will increment I 1 at a time every time we pass through the loop. So we'll start at the upper curly bracket, execute everything down to the ending curly bracket, go back on up, increment I, test it to see if I is still less than 8. If it is, we keep executing. Once I is equal to 8, we've executed this 8 times, and now we have 8 samples of analog read on pin volts in. So that's where we come up with our 8 samples in there. Once we drop out of the loop, we'll then create an average null count, take that samples divided by 8 and store it in null counts. That's everything for setup. Now here's the entire loop. It's very simple. Most of it is displaying what's happening up here. I decided I'm going to take an average of my samples of 8, and that's done right up here. So in this case, again, I set the sample sum equal to 0, go and do 8 samples, sum those all up, and then my counts equal to sample sum divided by 8. So now I've got an 8 count or 8 sample average in there. Now I calculate then my difference by subtracting my counts from my null counts, and there's my difference. And I'm doing a little loop here, not a loop I should say, but a little structure, decision structure. If the absolute value of my difference is less than 3, so if the difference is -2, -1, 0, +1, or +2, I'm going to turn the yellow light on. So here I write yellow LED high and red LED and green LED off. If it's outside of that range, meaning it's +3 or above or -3 or below, then we're going to turn the red or green LED on. And now I'm going to go test. If it's greater than 0, which means it's positive, so I'm going to turn the green LED on. Turn the other 2 off. Otherwise, only thing left is for it to be negative. And in that case, what I'm going to do is I'm going to turn the red LED on and the other 2 off. Make sure you do not just turn one LED on and forget the other 2. because after a few cycles you'll have all 3 LEDs on and no one will ever turn off. Now at the bottom here, I do a little serial print, counts. So my counts there, difference, diff counts, and I do a new line, the delay 100 milliseconds, and then off we go, do the loop again. That's it. So as you run this software, you'll be able to see the counts changing on the screen. You'll see the LEDs go up and minus. The LEDs are nice because you've got a reference point that you can go to, and as you get closer to something, you'll see the LED turn on or off. The counts will provide you a relative distance, relative intensity. As things are more or less intense, the numbers will change and increase. So you can go on to the software and operation. You can watch that happen. That's another video. I broke that out into a separate video for you.